Thank you, John. John, you forgot that the secret to successful presentations is much like the secret to successful marriage.
Wow.
Low expectations.
Okay.
So we want to keep the expectations low. Thank you for that introduction. Thank you, everybody, for being here at AU, South Africa. I am really personally thrilled to be here. I have a global role at Autodesk. I manage our global named account program. That's our strategic customer program. And as such, I get to travel literally around the world and see many interesting places. But this is my first visit to South Africa and to Cape Town, and I'm already falling in love with the place. This is one of the best kept secrets in the world. It really, really is. This week I had the pleasure to hike on Table Mountain, to explore down the peninsula to the Cape, to see some amazing landscape. But of course, today we're going to talk about a different landscape. We're going to talk about the landscape of ideas, of technology. And this landscape we call the future of making things. You heard Andrew refer to it in his welcome video. And this is a topic that's really near and dear to our heart. It's something that if you've been involved in the Autodesk conversation for the past few years, we've been talking a lot about this. And we have a very particular point of view about where the future is going in terms of how we make anything. And in fact, we see a number of significant disruptions in the nature of demographics, consumer demand, and of course, technology. And these disruptions represent simultaneously tremendous opportunity to add new value, to generate new revenue streams, and also threats. Because if we ignore these trends, if we ignore these disruptions, you can believe your competitors will not. All right? So I'm going to touch on just a few today. I'm not going to go very deep because we've had this conversation for a few years, but I want to make sure we're level set. And then later, a couple of my colleagues will go much deeper in a couple of these areas that we think are particularly pertinent right now. But let me start with, when we think about the technology disruptions and opportunities out there, we tend to categorize them in three buckets. First of all, disruptions in the means of production. And when I say production, I mean both physical production, the making of things, automobiles and copiers and buildings, and also the production of ideas, intellectual production. The next big trend we're going to look at is connectivity or connection. The world is moving to a connected state. And that has tremendous implications on what we build and what our expectations are for how we interact with the things that we build. And then finally, I'm going to touch on a disruption that is kind of an Uber disruption that's accelerating all the rest, and that's machine learning. And that's something we're going to talk a lot about today because it is so compelling and so important that we understand how this is going to impact our lives and our businesses going forward. So let's start with production. So again, when we talk about production, we could be talking about physical production, such as this robot bricklayer that you see in the photograph here. That's a real thing, by the way. Or we could be talking about intellectual production. When I talk about intellectual production, it's how we design, it's how we create ideas and explore the solution space. If you think about technologies like generative design, we can now design things in a way that no human ever would have done on their own before. We can design artifacts, for example, for the aerospace, the automotive industry, that are lightweight, twice as strong, much more sustainable in their manufacturing processes. But the catch is, how do you build such a thing? Because most of these objects can't be built using traditional manufacturing techniques. So when we talk about production, we have to look at that connection between how we generate the ideas and then how we implement them. And here's a good example. Boeing, aircraft manufacturer. I flew on one coming over here. They will very shortly begin producing 3D printed titanium components for the 787 Dreamliner. And if you think about how regulated the aerospace industry is, how many certifications you have to go through for every part that goes on an airplane, you realize that if they're now putting generatively designed 3D printed components into that plane, it must be real. The future of making things, it's already here today. What about that intellectual production? Well, there's many, many things we could talk about here, but one that's really important, and I think critical for South Africa in particular, is the notion that no major project anywhere in the world today is done in a single location. Major projects, whether they're designing an aircraft or building a major piece of infrastructure, involve teams that are separated by thousands of kilometers of space and many time zones. How do you get those teams to work and collaborate effectively? How do you, especially when they have different points of view, they're coming from different areas of expertise, the designer, the engineer, the manufacturer. Well, increasingly we see the disruptive trend of virtual and augmented reality, enabling these teams to collaborate despite time and distance. In a way, it's like adding body language to the conversation. And of course, where we think this is going, it may sound far-fetched today, but where we think this is going is eventually, as designed, will become as built. We're going to push a button to make, and we'll think no more of it than we think today about pushing the print button and expect the document to come out on that HP printer. We will see machine algorithms that will seamlessly integrate the phases of ideation, design, engineering, and manufacturing, fill in those blanks for us. We'll send digital streams of instructions to factories that will self-configure to build whatever it is you just designed. Sound far-fetched? It's coming faster than you know. Let's talk about connection. Our expectations for the relationship with the products that are being built today is changing rapidly. We expect those products to be smart, whether it's an automobile or a highway. We expect these things to get smarter and better over time, rather than growing obsolete the moment that they roll off the assembly line. We expect these products, buildings, to talk to each other, to deliver an experience that is unique to the environment in which they sit, that makes it more compelling than the sum of the parts. And of course, I'm talking about the Internet of Things here. But the Internet of Things, in and of itself, isn't very useful. It produces petabytes of data, but what do you do with that data? How do you turn that into information and into insight? Well, that brings us to the third major disruption, machine learning. Machine learning is really accelerating those other two disruptions, the disruptions in production and the disruption in connection. Because it's only through the power of machine learning, big data analytics, and so forth, that we'll be able to make use of all of that connected data and information. Of course, machine learning is a very broad category, and my colleague Tom is going to come up in a moment and tell you a lot more about it. But of course, it encompasses things like generative design, which I've already mentioned, robotics, AI. Really, the sky's the limit here. And again, much of this sounds like science fiction, but in fact, it's science reality. Now, there's a legitimate fear that robotics and AI is going to impact jobs. It may replace human beings in many tasks that are dangerous or repetitive today. But the fact of the matter is that in every era where we've seen a disruption of game-changing technology, whether it was the steam engine, electricity, whatever it might be, the automobile, it's always created more opportunity and more jobs than it ever displaced. So we need to embrace this reality, because we're not going to stop the tide. We've got to ride that tide, and we've got to take advantage of everything it brings to us. So production, connection, machine learning, major technology trends, creating, as I said, both opportunity and risk. The risk is that we don't embrace the opportunity. But there's one more disruption I want to talk about, and it's not necessarily a technology one, but it's one that is absolutely in front of mind for Autodesk, and I think very relevant for Africa as well. And that is resources. We are reaching the limits of what our planet can sustain, And we have to think about sustainability in everything we do. It has to inform the way we engineer, design, and produce all the products and services that we deliver today. Why is this so acute right now? Today, there's 7.5 billion people in the world. In 30 years, there'll be 7 billion people living in cities alone. Think about that. Just to build housing for those 7 billion people, we're going to have to build 1,000 buildings a day, every day between now and 2050. How are we going to do that? I think, again, Africa, more than most continents, understands the challenge of building sustainable, effective housing for large populations. So to keep pace with this, we're going to have to support many organizations and many fresh ideas. One great example is the organization Water for People. They've got a fantastic mission. Their mission is to go to specific areas in the world and make sure they have access to clean water and sanitation. Their motto is clean water for everyone, forever. Think about that as a mission statement. For everyone, forever. And of course, we're very proud to support organizations like this by donating technology and know-how to help them achieve their mission. A little bit closer to home, we had the Midland, Maine Central Square project in Pretoria. This is a fantastic experiment in sustainable urban design. It, in fact, is an urban laboratory, if you will, of mixed use, work, play, living, in an environment that's designed to not only create zero emissions, but negative emissions. The architects for this project will tell you that there are only 19 green cities on the planet today, and this is the first one in the continent of Africa. Again, very, very proud to be part of supporting such a forward-looking activity. Let me go further north to Holland, to Amsterdam, where we see Royal BAM has built this fantastic new pavilion for the ABN AMRO Bank. Now, what's special about this pavilion is that everything about it is designed with reuse and sustainability in mind. First of all, it's built with all reused products. Everything from the doors, the windows, beams, fire hoses are repurposed from previous constructions. And all of this material already has planned reuse for when the project is eventually torn down at some number of years in the future. The employees themselves even donated blue jeans that are being used as part of the insulation and decoration inside the project. Really, really innovative. In fact, BAM calls this circular design and construction because it represents a continuous, ongoing cycle of reuse. And they're onto something here because it's estimated that there's a $5.5 trillion opportunity in sustainable goods and services over the next 10 years. And they're on the forefront of figuring out how to do that. So we've got a world of opportunity in front of us, a world of fictional sounding disruptions, machine intelligence and connectivity and smart products, and of course this underlying need to do it all sustainably. Is this real? Is it happening today? Well, yes, it is, of course. And I'd like to share a couple of examples of other companies that are taking advantage of these technologies to change the game within their industries. This is the Vama 12 plant in Norway. It's the country's largest hydroelectric plant. It's over 100 years old, but Norconsult was given the job of redesigning and modernizing this and making it a world-class piece of infrastructure. And they did that by bringing to bear every piece of technology they could. First of all, it's an entirely BIM-based project from beginning to end. You also see here they're taking advantage of computational design, in this case a product that allows them to very precisely calculate the steel meshes, the rebar for reinforcing complex concrete structures like the turbine housing that you see here. But the use of technology didn't end with the design phase. They also took it to the field using scanners and drones. They were able to create digital models of the existing structure and use that to integrate the new structures in. And of course, The site superintendents had tablets with the BIM models so that they could continuously compare construction to the model and catch problems early enough before they became a major disaster. At the end of the day, Norconsult didn't just build a world-class hydroelectric plant. They set a new standard for how such plants will be designed and constructed far into the future. Let me give you another example. This is the Port of Rotterdam. At the Port of Rotterdam, they have a fantastic forward-looking organization called the Additive Manufacturing Lab, or RAM Lab. RAM Lab is looking at bringing advanced design and manufacturing techniques to the world of shipping. So what you see here is the world's first large-scale shipping components that are being 3D printed in steel. All right? It's a hybrid process that involves advanced multi-axis milling, state-of-the-art technology there, as well as 3D printing. They're going to revolutionize the retrofitting of ships. So when you think about an expensive ship sitting in port, needs a new propeller, it could be there for months. That's millions of dollars of lost productivity for the ship owner. The only other way to combat that is to maintain expensive stockpiles around the world, and that's not cost-effective either. Of course, they don't intend to stop here. They believe that this same technology can be used to impact the oil and gas industry, the automotive industry, and many others where the transportation of material to a site may be cost prohibitive. Think about Africa, where it's twice as expensive to travel anywhere here as it is in any other continent. Being able to build on site, even something as industrial scale as a ship's propeller, could be a game changer. All right, so the emergence of the cloud, which is the underlying compute engine that allows us to have these technological disruptions in production, disruptions in connection, machine learning, is a fantastic platform. But where do we go from here? What's next? What's the next big platform? Well, I'll submit to you the next big platform is data. Again, we talked about it's going to be a connected world. We're going to have sensors everywhere. But what do you do with all that information? Well, Autodesk's role in this is really quite simply to use that information to feed back into the design and manufacturing process. Close the loop between design, use, and manufacture. With that data, we'll be able to drive even more impressive technologies in the artificial intelligence domain and the domain of generative design. So at this point, I want to go a little deeper into this topic because this is so important, so game-changing, that it's worth doing a double-click on. And to do that, I'm going to invite my colleague, Tom Wujek. Tom is a fellow of Autodesk. We only have 2 or 3 of those. He is an author, he's a facilitator, and he's the most interesting man in the world. So